Your what?
My hair is not Karen length anymore.
Or I'd like to see the manager.
Excuse me, I'd like to see the manager, please. This is unacceptable. I once did that in a Starbucks, and I genuinely frightened one of the employees because she.
I will not. I tell you, those women that have the bob cuts, no way. They scare me.
It's the only way my hair is manageable, but I've not pulled a Karen yet.
You don't count. You manage everything flawlessly all the time.
You haven't seen this mess on my head.
Oh, yeah. Yeah. Let me go ahead and turn on this as well as present. Can y'all see my laptop screen?
Nope.
Okay. So, sorry about that. And as soon as I hooked up the office laptop, that's when it came on. I knew it would. So I did figure out one thing. Let me get another black marker. I figured out where the -1 came from. So let me go ahead and show you where that came from. So we were doing this problem. I'm going to have to turn this around. Okay. And make this bigger. And get rid of all the stuff on the side. There we go. We were doing this problem. T of y is equal to y times the natural log of 1 over y. And we got the answer, but we didn't have the right sign. And the reason that is because of the y to the -1. That's why. So first times the derivative of the second, I'll do that in green, natural log of 1 over y prime, plus the second times the derivative of the first. I actually had a fever because of my spider bite. I had to call the doctor. Y'all don't care.
You just want us to feel sorry for him.
What? Okay.
You said you're wanting us to
tomorrow. Y'all just send me a card. Say, I'm sorry I made fun of you. That's all right. What? Why?
I wouldn't hobble over to the mailbox.
Times. Thanks. And I'm going to write this out so y'all don't screw it up. I'm going to take the derivative d dx of 1 over y over 1 over y, because that's how you take the derivative of the natural log. Okay? Plus natural log of 1 over y times 1. Now I'm going to rewrite this y times dy or d dx of y to the -1 over 1 over y. And there's where the negative comes from. Plus, but if you skip steps, you don't see it. That's why I didn't see it, because I skipped some steps yesterday. Natural log of 1 over y. Now the derivative of this is, let's say, y times, and that's going to be -1 y to the -2 over 1 over y, plus the natural log of 1 over y. Now, this right here can be rewritten, and I'm fixing to rewrite it in an algebraic way. We'll go over here. Y over 1 times negative 1 over y squared and when you divide by a fraction, you multiply by the what? Reciprocal. And of course you see the y's cancel and you're left with what? Negative 1 plus natural log 1 over y. So there's the problem that we did yesterday, and I couldn't get the negative, and that's why, because we skipped these 2 steps right here and this step. So hopefully you can see that now. Because you will see, and I'm going to tell you this, on a placement test or on a regular test of mine, you're going to see natural logs, and that would be a good one. Capiche? Okay, now that's leaving off of yesterday. So I picked up another couple of problems. I figured if that wouldn't discourage you enough, we'd do one that discouraged you big time. So j of x is equal to the natural log of 4x minus 1 to the 8th power times 3x squared plus 14 to the 7th power over the square root of x squared minus 4. And of course, what would you do with this if you saw it on a test?
Quit.
Yep. Skip it. So, what should you do? Well, before you do anything, you need to rewrite with logs. I want you to do that right quick. You're going to rewrite this problem using the properties of logarithms. No calculus, just algebra. Which you really, really, really do what? Suck at. So, let's go ahead and do it. Rewrite this as logarithms. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Got 19 today. Only got about 10 missing today. What that was. So, first thing I'm going to do is I'm going to rewrite natural log 4x minus 1 to the 8th power, 3x squared plus 14 to the 7th power, x squared minus 4 to the 1/2 power. And now I'm going to do my logarithms. Logarithmic rule 1 is if you're multiplying 2 logarithms, you can rewrite them as adding. natural log of 4x minus 1 to the 8th power plus natural log of 3x squared plus 14 to the 7th power minus natural log of x squared minus 4 to the 1/2 power. Now, are we done there? Is there any more logarithmic rules we can use?
You could
Yes.
bring the exponent out front.
Good job, the power rule. That gives us 8 natural log of 4x minus 1. And now you just have to take the derivative and put it over itself. See how nice this is? Now, why would I put this problem on a test?
To torture us?
What?
To torture us?
No.
Discourage us.
To show you that sometimes a problem isn't as complicated as what? As it looks. Now, the calculus on this is very easy. What's the derivative of 4x minus 1? 4, Hubert. That's right, class. So 8 times 4 over 4x minus 1 plus 7 times 6x over 3x squared plus 14 minus 1/2 2x over x squared minus 4. 32 over 4x minus 1 plus, what is 7 times 6? 42. Yeah. 42x over 3x squared plus 14. And the 2's cancel, and you're left with x over x squared minus 4. And we're going to highlight the calculus in this problem.
Priority 1 message coming in on secured channel.
There's the calculus in the problem. So what makes up the rest of the problem? I believe you'd say algebra. There's your answer. Now, you don't have to do every single step, but I write every single step because some of y'all probably forgot about these 3 right here. I guarantee you somebody in there, somebody out there, oh yeah, I remember that. So the pink is only calculus. Capiche? Okay, nobody's going to talk to me. Y'all only talk to me when you're making fun of me. Okay. Let's try nerding. K of S is equal to log base 2, parentheses, 5s to the 8th minus 11 raised to the 3rd power. What does the change base formula tell us? Come on, somebody knows. Just type it in. I'm looking at the conversation. What does the change base formula tell us if you don't want to? Okay. The change base formula, when you have a base that's different from log base E or log base 10, remember log base E is natural log. Log base E is equal to natural log. Log base 10 is equal to log. So if you don't have these two, you've got to use the change base formula. And the change base formula says, I'm going to take the log of this guy.
Man.
Huh? What?
Oh, Alabama.
Will y'all leave me alone? Log base 10 of 5s to the 8 minus 11 raised to the third power over log base 10 of 2. Now this one is kind of tricky because I'm fixing to do something now that you probably hadn't seen. Well, you've seen the first part of it. The power rule says that bring that 3 out front. 3 times the natural log, or log, of 5s to the 8 minus 11 over nat log of 2. And I can rewrite this as 3 over the natural log of 2 times log of 5s to the 8 minus 11 over 1. And now first times the derivative of second plus the second times the derivative of first. So go to it. Somebody tell me what this is right here before we start. Somebody tell me what this is right here.
I can't get the stupid bar to go away to even see the bottom.
Say again.
I can't get the bar to go away to see what's on the bottom.
There, how's that? 3 natural log of 2. What is 3 natural log of 2? Anybody want to take a guess at it? It's a constant, Hubert. Yes, it's a constant. So what's that going to do to your second times the first times derivative of the second? What's it going to do?
Go away.
It's going to go out. It's going to take out. So let's go ahead and write it down. First, 3 over natural log of 2 times the derivative of the second, log of 5s to the 8 minus 11 prime, plus the second times the derivative of the first. The reason I didn't write all of that down is because 3 over the natural log of 2 is a number, and that number goes to 0, so that whole term goes to 0. So you're just left with this. And all you got to do here is do the derivative here and put it over itself. So that's going to be 40s over 5s to the 8th minus 11. I'm going to fold this in half. Where do y'all get some of this stuff? So that's going to be 3 over the natural log of 2 times, take the derivative. The derivative of what's inside is 40s to the 7th over 5s to the 8th minus 11. And 3 times 40 is 120 s to the 7th over natural log of 2 times 5s8 minus 11. Question, Mr. O'Quinn. I thought he had a hand up.
He does.
What's the question, Mr. O'Quinn?
He says he has a question in the chat. No microphone today. He asked, is there any reason to use base 10 as opposed to base E?
No, it's just a preference. Some people, like I don't use natural logs a lot. When I'm teaching, I use log, but I could use natural log. It's just the same. There's no, it's kind of like, what's the difference between using 1/2 and 0.5? It's the same thing. Okay. That's a test question, so you might want to write that one down. That's a test question too. All of these, what I did is I found a worksheet that had all types of derivatives on it. And those are the type derivatives that I'm going to ask you on a test. I'm not going to ask you who attended Wimbledon and what were their addresses, like some of your homework questions. I'm not going to ask that. Okay. A of S is equal to 2 sine squared S. Yeah, this will make y'all quit. Plus 2 cosine squared S. Derivative of the sine is cosine. Derivative of cosine is a negative sine. Well, if I just throw that in there, you're going to get 2 sine be cosine squared. Well, sine times cosine squared. Yeah. Sine times cosine plus 2. And what's the derivative of the cosine? The negative sign. And what's that negative going to do to this? It's going to minus it. So that's going to cancel and you get 0. That's one way to do it. Another way to do it is just to use algebra. A of S is equal to 2 sine of 2. I think that's what you're talking about, Mr. O'Quinn. Plus 2 cosine. And if you remember your Pythagorean identity, factor out 2. And that's sine squared plus cosine squared, which is equal to 1. So A of S is equal to 2. Therefore, A prime of S is equal to 0. So in that case, you could do either one. I would suggest you just use the Pythagorean because now, why would I put that on a test? Because this kind of problem would be on a standardized placement test because it's got the trig and it's got the identities. Okay, so just remember when you got the identities, when you got the trig identities present, you can do it more than one way. Okay, so that's one for the placement books, for the standardized test books. B of t is equal to 4 natural log 5 cosine of t. Now remember, the natural log of something is the derivative over what you originally started with. Derivative of cosine is a negative sign. What's wrong? Derivative of cosine is negative sign. So go ahead and work that problem. Now y'all should be able to do this one. If you can't do this one, then you might as well just wrap it up and just go ahead and find a liberal arts major that you want to go into. Global studies. Let me think of another one. What's that girl that's in the Senate? She got hers in, I think hers was global studies. Yeah. From bartender to global studies. Nobody
Should ask her
didn't-
that joke about if you're French before you go into the bathroom and you're, Swedish or Swiss when you come out of the bathroom, what are you in between? Bet she'd like that.
You'll have to explain that one to me later. Oh me, that sounds like I don't even want to ask, but maybe later. All right, so we've got 4 times, well, the derivative of this right here is going to be 5 times negative sine of t, and all that's over 5 cosine of t. And for these 5s, what do? They cancel, and you're left with negative 4 sine t over cosine t. What's our final answer? And that is a standardized test question as well as one of my test questions. Question, gripe, complaint. F of W. Now, if you're from around here, it's W, but W is equal to tan of W squared plus 1. Now, this one is not difficult. It's real simple. You got to take the derivative of tan, the derivative of the tangent is equal to the secant squared. And then take the derivative of what's inside. So that's going to be secant squared of W squared plus 1 times the derivative of what's inside. 2W secant squared of W squared plus 1. Another good, but as you can see though, you don't go into the analyzation with the trig functions as you do with the algebra. The algebra usually takes up a page or 2. The trig functions, they don't take up that much because it's basically on a lot of memorization. Here's some simple ones. F of t is equal to 3e to the 4t. Now, the reason I'm showing you this one is I don't want you to forget how to do e of t or e of the function. So, because you're going to see those on standardized tests. And here, you can do the product rule if you wanted to, or you could just do the function e of 4t like normal. 3e to the 4t, the derivative of e to the 4t is e to the 4t. So 3e to the 4t, and that's in the parentheses, and the derivative, what's inside, is 4. So that's going to be 12e to the 4t. So don't let something on a test, don't let that confuse you on the test. You could actually do this with the product rule. First times the derivative of the second plus the second times the derivative of the first. And what happens to the second term? Goes to 0, and that leaves you with 3 times e to the 4t, and then derivative 4t is 4, which gives you 12e to the 4t. So you can do it either way. You can do it with the product rule, or you can do it with the power rule, technically. G of w is equal to e to the third over 3 to the w. I'm going to let y'all do that one. E to the 3 over 3 to the w. What do you think I'm going to do? What would be the easiest thing to do? Besides quit. What would be the easiest thing to do?
Quotient rule.
You could, but why am I saying you could? What would be easier than the quotient rule? Anybody? Nothing. What's easier than the quotient rule? Product rule, Hubert. Good. The product rule. Bring that 3 to the w upstairs, and you have 3 to the negative w. Now, you don't have to do that. You can do either one. E to the 3 times 3 to the negative w. First times the derivative of the second plus the second times the derivative of, and what is the derivative of e to the 3? That's going to be 0, so that's going to 0 that whole thing out. And this is a number raised to an exponent, and the derivative of a number raised to an exponent is the natural log of that number. So the final answer is going to be e to the third times 3e to the w times the natural log of 3. Sorry, natural log of 3. And you can rewrite that as e to the third natural log of 3 over 3 to the w. Yes, Mr. Quinn, that goes to 0. g of x is equal to x squared times e to the x squared. X squared times e to the x squared. So of course, you're going to do first times the derivative of the second plus the second times the derivative of the first.
So right here you have MSNBC.
I can't turn off anything. Hey, gum, somebody sent me something, I couldn't turn it off. So first, times the derivative of the second, and I'll do that in green, e to the x squared. So that is a number to a exponential variable. It's just like 2 to the x, where you have to take the natural log of 2 times 2 to the x. Leave me alone. Plus the second times the derivative of the first. I wasn't able to turn my computer on, thank you. So that's going to give me x squared, and that's going to give me e to the x squared times 2x, because I take the derivative of what's inside, right there, plus e to the x squared times 2x. And that's pretty much it. Turn it around. 2x to the third e to the x squared plus 2x e to the x squared. Yes, you could factor out something. Yeah, you could do all that, but I'm not worried about that right now. Here's one that you might see on a standardized test. F of x is equal to pi e squared. And what should you put down as the answer?
0.
0. Good
Priority
job.
1 message coming in on secured channel.
Here's one that you might think is difficult. The derivative of tangent of 3t is secant squared 3t. And then what's the derivative of 3t?
Three.
That's it. Okay, now I have pretty much covered chapter 3. Now, that means if I don't get any questions this next, let's say tomorrow's Thursday, if I don't get questions Thursday, we're going to go ahead and start the test. Well, I haven't got any questions from y'all. So that either means that I'm doing a wonderful job in teaching you this stuff, and y'all are doing your homework, and you're doing very well, or it means that some of y'all aren't doing the homework, and you're not sending any questions. One of those two things. I'm gonna believe it's the former, because I don't want to believe it's the latter. I could pull up right quick. Well, let me do that right quick. I'm gonna stop presenting. And I'm gonna pull up. Let's see how much y'all are doing. Give y'all a second to get your excuses together. Let me pull up the handy dandy MyLabs Plus. I also got to pull up the, let me go ahead and stop the recording too. Computer is really slow.